Good morning, good afternoon, everyone. I hope you can hear me. And welcome to the fourth session of the second conference on forced displacement. My name is Christelle Cazabat, and I will be your chair for the next hour and a half. I'm the research manager at the Internal Displacement Monitoring Center. I will just give us a few more seconds to join and settle in for this second session of the day. Okay, so we are now 2 minutes past the time of our session. So I propose we begin. And welcome again to this fourth session that will focus on innovations in data collection. Now, as we all know here today, forcibly displaced people are often missing or underrepresented in official statistics or more traditional data sources. Yet information on IDPs and refugees and asylum seekers is needed to accompany them better. So the researchers who were selected for this session have demonstrated in their papers how innovative data collection methods can be used to bridge this gap. In the next hour and a half, we will hear 3 presentations on the use of survey microdata and gridded meteorological data to analyze internal displacement linked with water scarcity in Brazil, on mobile phone data to measure internal displacement linked with violence in Afghanistan, and on automated surveys over WhatsApp to survey refugees and migrants in Colombia and in the US. But first, a few words to our audience. If you're joining via WebEx, please write any question you may have in the chat, and I will select a few of them so that our panelists can respond to them at the end. But if you are joining us via YouTube, you may also write your questions in the chat section in YouTube, and we will keep monitoring this as well. Note that you have to be logged in to YouTube with your account to be able to do this. All right. So without further ado, I propose we begin with the first presentation, and I will remind our speakers to please stick to about 20 minutes for the presentations, so we have some time for questions and answers. The first topic that we will cover is about drought-induced migration in Brazil, a quantitative analysis of internal displacement from the Northeast region due to water scarcity using survey microdata and gridded meteorological data. A fascinating topic. I really look forward to your presentation. We have 2 speakers for this topic today. Guilherme Dutra, postgraduate with specialization as a candidate in data science and big data at PUC, Minas, and currently based in the Republic of Korea. And Marianne Broom, who holds a master's degree in hydroinformatics and water management and is currently based in Germany. Now, the others will tell us how they use big data from geosciences and microdata from statistical surveying methodologies to show the connection between environmental factors and internal displacement in Brazil. Over to you both.
Thank you very much, Christelle, for this introduction. Let me just share my screen with our presentation. Hopefully you're seeing it now.
Yes, we are.
Perfect. So hello, everyone. It's a pleasure to be here. Thank you very much, Christelle, for the introduction, for the other panelists who are here, for everyone who's watching us today, and of course, to the hosts of this wonderful conference. And although we cannot meet in person in Bogota this time, hopefully soon we can. And this is already has been an interesting experience, albeit online. We have seen many interesting presentations today and yesterday. So I'd like to start the presentation as Christelle mentioned. We're examining drought-induced migration in Brazil. I'm Guilherme Dutra. I'm a survey and data consultant based in the Republic of Korea. And I'm joined by my colleague Mariani. Mariani, if you can say a few words about you. Mariani?
I think you are muted.
I think you're muted.
Aren't you?
Oh, I think there might be some, well, then Mariani can check if it's working because we're not hearing you. Perfect. Okay, Mariani is a research engineering consultant in Germany. You're gonna hear more from her later. So our research examines the issue of internal displacement through both the big data perspective and the microdata perspective. These are our table of contents. Let's start with our starting points. Our starting point is this notorious phenomenon in Brazil of migration from northeast to the southeast that is commonly associated to drought. And there's an extensive body of literature, this literature, both research literature and also fiction literature, that connects both of these, both drought and migration, mostly to the southeast, but also to other parts of the country. So our initial idea was trying to understand, when we think about drought, the first idea comes, of course, meteorological data, big data. And when we think of migration, microdata. This is still the traditional way for measuring internal migration. And so our main starting point is, so how does this work together? So here are some images of how this is part of the imagination of the Brazilian, would say, and this connection. But the reality is that there's limited quantitative evidence, especially for the first decade of the 20th century, which is the decade we analyze, on how this connection actually is. So here are two starting points, as I mentioned. The main starting point and the main research question we have is the methodological possibilities and challenges for integrating big data and survey microdata in migration research. And I think this is a question that's in the mind of many people who work with microdata nowadays, as we know that this is this whole buzzword of big data, and we working on these traditional data collection mechanisms for in the social science that we know are still the best quality data we can have. How can we leverage this whole possibility of open big data out there? And we hope to bring a little contribution to this discussion. And in this case, specifically of the survey of the internal drought-induced migration from the northeast to the southeast region of Brazil, is a bit of a contextualization of this methodological discussion. So a little bit of a literature review. As I said, this is a really commonly perceived phenomenon that became stronger in the 60s and 70s in Brazil, from migration from the northeast to the southeast. And there has been an understanding that this changed in the 80s due to limited economic opportunities in the southeast. And now there's a trend of return migration. And the question is drought still a push factor now in the 2000s to 2015, now in the 21st century? Because this is the part that's not really well understood. And as I said as well, we have several studies. For example, we have qualitative studies that investigate the role of drought in on the creation of the identity of the northeastern person. But this is extremely limited still, in the sense that we don't have a clear idea on how this is connected in more quantitative terms. And I would like to highlight two studies that use census data. And this is the part of the main use in the literature is using census data, not sample survey, as the one we use for PennAd, which takes a smaller sample, a really small sample. And these studies found an evidence for drought, but not for the period they're analyzing, using census data. So, and they analyze at the municipality level, and we analyze at the state level, which is another difference as well, that due to the nature of our big data, we ended up with the conclusion that state level would be better. And PennAd is a source of migration data. That's lots of mentions in the literature to the importance of PennAd for measuring migration. This is a survey that has been carried out since 1967 in Brazil. So you have yearly cross-sectional data, but although there are many mentions, it hasn't been used as much as it should, we believe. And so some issues that we found, methodological issues, probably is the no inclusion of the rural zones of the northern region until 2004, and also the estimates for small northeastern states, which are expected in a sample survey such as PennAd. And most of the analysis using PennAd data is mostly descriptive. So the PNAD, as I said, this is the data we use for the microdata side. We use from 2001 to 2015. It's yearly data. So there are several cross sections that we pulled to analyze it as a whole, and it measures several characteristics. And good for us, it included a migration module. This PNAD has been replaced for something called PNAD continuous. So this is important to highlight that nowadays the PNAD is different. It's a panel survey, panel design that collects data quarterly. So it's incomparable to this one that was used before, this PNAD, but we use because this is the only one we have for this decade. That's the decade of interest. And it's organized in 36 strata. It works that it has strata specifically for the metropolitan regions, and then it creates strata for the states, and for the states not metropolitan region. And for the metropolitan region strata, it uses 2-stage sampling. For the strata, 3-stage sampling. Gladly, the R survey package takes care of the most part of our complex survey design, and that's what we use for the estimates we're going to see today. It surveys approximately 150,000 households every year. It's surveyed. So the criteria for estimating migration, the PNAD uses the standard criteria for estimating migration in the population surveys, which is a fixed date 5 years before the reference period. This is a common methodological guideline. And migrant defined as the individual older than 5 years old who was living in a UF or state. It's the same in Brazil, different from the current state of residence 5 years before the reference period. So it allows us, if you see there, number one, it allows us to measure how many people migrated during a 5-year period. This is the common use for this PNAD data in the literature, is having 5 years, 5 years, 5 years, 5 years. So it's aggregated at 5 years. And these point estimates are the ones that are the best point estimates you can get from PNAD on migration. There's another way of doing this that we use here, which is taking as well the variable where you ask for the residence time in the current state. And then the person is going to answer, well, this number of years. The thing is, since we're taking different samples of individuals every year you're going to get different answers. So we got to get numbers all over the place. And then we explain how we adjusted later for this. But this is another way of getting more precise estimates in the sense of trying to know how many years this person probably migrated, but then the standard errors go wild. That's the reality. And this is one of the methodological challenges we're going to discuss later as well. So here's the drought migration meteorological data. Mariani, working? Oh, it's still muted.
Out. Can you hear me now?
Oh, now I can. Yes.
Yeah. Okay. Yeah. It's sorry about that. It's microphone issue. All right. Let's go for it. So I'm going to be discussing our drought data, so the data that we used in order to define drought and estimate it, and also discuss a little bit the ranking process that we use in order to get it to the format where we can connect it to the survey data. So what we use this Global Precipitation Climatology Center Drought Index, which is an index that is freely available, calculated by the Global Precipitation Climatology Center and distributed by the Deutsche Wetterdienst, so the German meteorological center. And this is a grid product, which means that it comes in a grid. And there are several factors why we decided to use a gridded data instead of, for example, using station data, which most people do use. So factors are actually accuracy of the data, so data quality. This is something that we wanted to focus on getting better data in order to do our survey. But also we wanted to focus as well on getting data throughout the world. So there are several regions where data is not freely available or not easily available because station maintenance is expensive. Also, stations sometimes change places, which makes it difficult to do an analysis throughout a longer time frame. And also coverage of the data. So for example, for this product, we have data from 1959 to 2021. That's pretty good coverage. So this product gives us monthly time resolution from 1 through 6, 9, 12 to 48 month aggregation periods, and at 1 degree spatial resolution, which is a pretty good resolution. And it is derived from other commonly used indexes such as the SPI and the SPEI indexes, which take into consideration not just precipitation deficiency, so when it rains less than what we're used to, but also evapotranspiration, which is something that sometimes other indexes don't take into consideration. So when there is a lot of evaporation, sometimes it can be rainy normally, but you still get drought out of it. So please next. So in order to use this product, however,
Sorry.
in order to use this product, however, we need to first define what is drought. So we need to define the region of aggregation we're going to use and the temporal aggregation we're going to use. Since we're using this gridded product and we have a lot of flexibility on it, we can also decide on how we're going to aggregate it. And this is one of the main questions. So drought is defined both as a meteorological or hydrological drought. So meteorological drought is when it rains less than normal. And hydrological drought is when we have a longer period of loss of water in our rivers and in our groundwater. And this is what it has a more direct effect, when it affects more directly socioeconomic, the socioeconomic situation. So when you get actually impacts on agriculture and jobs and so on. So the hydrological drought has a longer time span, but is smaller in extension. So for that, because of that, you can go to the next slide. What we decided to do is use previous one. Yeah, thank you. Is use the 3-month aggregation product. So we're going to aggregate over 3 months, and each time there is a 3-month loss of precipitation. So according to those indexes, we're going to define that as a drought event, and we're going to aggregate that over microbasins. So a basin is a hydrological unit over which, in a very rough terms, if it rains within that area of a basin, we consider that water to flow into a river. And this is how actually hydrology mostly works. So if I am in a city and it's raining a little bit less in the city, it may not affect me as much as if it's raining a lot less in the basin, so in the river basin where I get my water from. And that's why we decided to use this aggregation measure instead of the more commonly used aggregation over municipalities. I believe that's more correct physically. So we did over that, and then over the microbases, we aggregated over states. And then we also looked into normalized and non-normalized results. And then the normalization is actually over the number of microbases, and also for 1 year and 5 year areas. So yeah, you can go on. That's just a map of Brazil. We can go on a little bit more. When we're looking into actual Brazil as basins, then we look into the macro area of the basins. You can look a little bit more. That's still a little bit too large in order to work with this data. So we decided to go into the micro basins, which actually look into the tributaries of those rivers. So the rivers that flow into these other rivers. So this is the map of the actual areas we use for aggregation. You can go on again. And this is a comparison between those aggregation areas that we've used and the normal municipality areas. You see there is a lot more municipalities as regions than there are microbasins. And this is a difference that we're going to find between our data and other studies that have been used. Yeah, go on. And overall, this is a general, very brief picture of what we've done. So we took this gridded data, we've aggregated it over microbasins, and then we've aggregated it over states in order to do the connection between the states, so the survey data over states, and the actual meteorological data. Good one. So this is how it looks in the end. We have these microbasins, and we have the indexes of drought. Here is from 1983, and we see the darker red ones are where there is more drought, so bigger lack of precipitation or precipitation deficiency. You can go on to the next one. And this is how they would be categorized if we looked into defining what drought is. So this is the category of drought. Yeah, you can go on. So taking a look again of deciding on how to aggregate it over time, I think this is something that's really important when we look into using big data, the connection between big data and survey microdata. If we aggregate over very large periods, so here we're looking over aggregations of 1 month, 12 months, and 5 years, we see that the effects of drought average out. So when we look at 5 years, it seems there has been no drought at all, which is of course not true when we look into 1 month. However, our survey microdata is in 5 years. So this is why we had to use that dummy variable, and we had to use definitions of drought that we chose ourselves. So 3 months and over the microbasin. Yeah, you can go on. And this is how it looks over the classification as well. We see the averaging out of drought. But it's also interesting to look that different states and different areas have very different spatial variabilities of drought. So this is quite important, and this is why we've decided to do our analysis over each state of the region instead of the whole region. So instead of averaging over the whole region, we've done a state-by-state analysis, and you can go on. So this is just a video of variation of drought. You can see that there's quite a bit of time and spatial variability in drought. You can go on. And just some brief description now of our data. So you can see for the different states, most of them, the most important thing that we can get out of this picture is there has been an increase in drought frequency. This is in line with what the literature says. We expect drought frequency to increase and also drought intensity to increase over time, which could lead to more migration, of course, bigger effects on migration. Yeah, good one. And then finally, we have here a very brief description of how the data that we generated in the end. So we see the normalized in the left and non-normalized on the right number of drought events over this 15 years of analysis. Yeah, you can go on.
Perfect. So now putting all these together, this is the 5-year estimates that I mentioned before. When we know data for the 5-year migration flows, we know that this person migrated within those 5 years from the Northeast. And our column of interest is out-migration from the Northeast because we're interested in seeing drought as a push factor for migration to the Southeast. And we adjusted this data, of course, for the population stock of the, I'll try to be brief here. And we adjusted it for the population stock of the Northeast on the start year of migration. So this is the 5-year estimates. You see migration for the Northeast to Southeast reduced. And in a similar proportion, it also reduced from the Southeast, as you can see. So what we can say is that out-migration from the Northeast has reduced in general, which is explained in the literature by probably the migration, the increased investment in infrastructure in the Northeast, and also the return migration movement instead of an out-migration movement. And the proportion in the Southeast, Northeast to Southeast, reduced in a similar way as well. So we are not seeing any differences on that. You see down there, the percent of total migration is still around 63.57. So when we look at states here, we started seeing some things interesting that here is not as clear, but you're going to see later that there is cases where when drought increased, there seem to have increased migration 1 year later or 2 years later. But in other states, when there's a reduction, it seems to have a decrease. When there's an increase in drought, there seems to have a reduction on migration by state. Here's a map showing that overall it has decreased the out-migration from the Northeast to Southeast. So here is the estimates using the yearly estimates, which as I said, are not the standard way that the literature does that because they introduce a lot of error due to the sample size and the characteristic of the Northeast. And the difference are really substantial when we see comparing the 5-year estimates from the PNAD with the 1-year estimates aggregated for 5 years. But we wanted to stretch the microdata as far as it could go and see how it handled the data. And when we take a look at these yearly estimates, we see a similar pattern. I wouldn't call a pattern, but there is some evidence that peaks in drought led to increased migration in some states and led to decreased migration in others. And we found 2 groups of states. Some had a positive correlation regarding drought and out-migration, and others had a negative correlation, which is a bit surprising, but is not completely surprising in the sense that these states are extremely different. And we had some hypotheses for these, which might be connected, for example, to the infrastructure of the state. Some people might prefer to migrate internally within the state or within the region and wouldn't take the effort to go to the Southeast, or which might be the new trend within the migration from Northeast, out-migration from the Northeast. Okay, and we ran pooled OLS regressions with this data. We didn't expect to find many significant relationships, and actually because we saw that there's these 2 different groups, but we wanted to test at this point, and we saw that there was a statistically significant for the model that includes moderate drought at T-1, but we believe this is more connected to model specification than to an actual effect. Future avenue for research will be studying this more in depth and building as well a model that takes this into account. more thoroughly. And when we use the 5-year estimates, which are the ones that are good point estimates, but really cumbersome to work with because we need to aggregate the big data at the 5-year level as well, which is problematically, we found no significant results. So here's the conclusions. I'm gonna be really brief because I think we're already over time. Apologies for that. So the main challenges that we saw is related to time resolution. Microdata is collected in larger time spans, like less periodically than big data. So in that's up that we have to simplify a lot the big data, and we have to stretch a lot the microdata to be able to make inferences connecting these two different types of data sources and not analyzing microdata within microdata itself, which is the traditional way for carrying out analysis. Marianne can finish.
Yeah, anyway, so, but however, we see that this meteorological data, so this big data, especially open data, has a lot of potential in the social sciences that we can use, especially for those reasons that we've discussed before. This data is usually available for a larger period of time. It has a better resolution. It is available basically everywhere. So this does bring up a lot of possibilities of exploring new research questions with it. It is a bit harder to wrangle, that is for sure, but there is a big community of people working on this, more on the environmental sciences, and we can perhaps do a little bit more connection between those things. So as a last point, we found really no significant evidence of drought-induced migration from the northeast to the southwest in this period that we evaluated. However, we found some limited evidence of drought affecting the states differently, which means that this could be perhaps a future avenue for research. Thank you very much. Sorry again for time and for the small technical problem.
No, you did very well. Thank you both. This is really fascinating, and you're just in time, so no problem at all. I just wanted to make sure we would have some time for questions, and we already have one. So without further ado, we'll start with maybe 1 or 2 questions before we move on to our next speaker. And the first one is, were there any assumptions or limitations in your methodology that you feel maybe affected the results, and that you'd like to discuss now?
Maybe I can mention a little bit on the modeling side. Our model is really simple at this point, so the results on the model, we haven't control for all the variables that we thought about. So we carry out a really simple pooled OLS regression with a dummy for year, but this is, in this sense, this is a limitation. So what we have is a descriptive part that we have some inferences, there are some correlations. And from the microdata side, the limitations of the data itself limit a lot the conclusions we can have. So there's the limitation on, for example, out migration to the northeast. We have not measured for 2001 to 2004. So in this sense, this greatly limits due both to our model specification and also to the limitations of our data itself, of microdata. Mario, on the big data side, maybe you have a...
Yeah, I can talk about, especially on us having to decide on, so we had to decide on, let's say, on limits on what is defining as a drought event. This is not ideal, especially when we're working with continuous data. Usually in meteorology, hydrology, we work with continuous data. Whenever we have to define limits, those are limits that have been looked at the literature level for a long time. And this is something that we just had to decide for ourselves because of the limitation of the connection with the microdata. So ideally, we would investigate it a bit more on how to how maybe to breach this problem, how to use drought intensity as well, not just drought frequency. These are things that we can explore in the future.
Great, and that's what it is, right? With innovative data collection methods and new methodologies, you're testing them out, and you're obviously here presenting a very promising approach, but that doesn't necessarily mean that you're right away going to find the right solution, the right model, and the results that you were expecting, in a sense. So, so thank you for presenting that and also highlighting some of the challenges. That's what we should do amongst researchers, and it's that's the most useful thing to do. Maybe just a quick follow-up question then from myself, really, before we move on. Have you already identified other contexts where you could apply a similar approach, you know, either in Brazil or in another country, or ways forward for this research, for this piece of your research? Or not yet?
Maybe I can mention, well, this data is out there, the big data is out there, it's open data, and we have data for, and these surveys are carried out as well. And we have, although PNAD is really good survey, I'll never say otherwise. It has really many limitations regarding the time aggregation that maybe other countries might not have on this microdata. And so it will even work better when we're using this method that we used for measuring meteorological aspects. So what we see going forward is not only bringing this data that is prepared side by side, because Mariana and I work a lot together on thinking about survey connecting to big data. And one conclusion that we came is that also surveys need to be thought, taking into consideration researchers who use big data and who are going to use this for big data research in the future. And I think it's a bit harder to say that big data needs to take into account microdata. I think for us here on the social sciences side, we're going to start thinking as well, devising surveys of making ways that they're going to be useful as well for analysis on big data later. So this is something that maybe there are several contexts to prove it even better than the Brazilian context. Mariana, please.
Yeah, what I can think about as much as using this open data is for using it in other contexts. We read a lot of the literature that is being done in Africa, especially where meteorological data is actually very limited there. So there is. I work with individual sciences, and we are starting to use a lot of satellite data within the African context, also in the Middle East, in order for us to do correlations between what's available there and try to fill those big gaps that already exist on this meteorological data whenever people are trying to do this connection. So I think this is a direct approach that can be used. So whenever we're trying to correlate so these environmental factors within the social factors, and also, yeah, of course, for this big topic that's coming up is climate change. So climate change induced migration. I think this is something that in the end we're going to have to try to use as well.
Absolutely. Thank you both very much again. If there are any more questions to Mariani and Guillermo, please post them in the chat box. And again, if you're joining us on YouTube, you can do the same. You just need to be logged into your YouTube account and post in the YouTube chat box, and we'll be monitoring that as well. But for the moment, I'd like to move on to our next speaker. And the next paper that will be presented is about violence and internal displacement, insights from nationwide mobile phone data. And this topic will be presented by our colleagues at the School of Information, University of California, Berkeley. They will tell us how they analyzed anonymized high-frequency mobile phone data to measure the short and the long-term impact of violence on internal displacement in Afghanistan. Please, over to you now.
Excellent.
Please go ahead.
Thanks so much, Christelle. Yeah. Hi, I'm Xiaowei Tai. I am currently a postdoc at the School of Information at UC Berkeley. So let me just share my screen. Can everyone see and hear me okay?
Yes, we can.
Okay, perfect. Yeah, so thank you so much to the organizers of this conference. It's really great to be here. So this is joint work with Shekhar Mehra and Joshua Blumenstock, as Christelle mentioned, where, oh, sorry, there's some note about, oh, it's not full screen.
No, it's not full screen. We can see it though, so don't worry too much about it. Yes, now it's full screen.
Okay. Where was I? So, we're at the School of Information at UC Berkeley. I usually like to start with some context on forced displacement, but I don't think this is really necessary for this audience. What I'll just reiterate is that border crises are really salient. We see them in the news very often. But what we see much less is about internal displacement. And as we've seen in the last day, there's this very commonly cited statistic where there's over 80 million forcibly displaced people, but more than half of them are actually internally displaced. So these internally displaced people are much less visible, as we've already seen, and very difficult to study. And one of the important reasons is the poor data quality. So there are many formal reporting procedures at borders, but this is not the case for internally displaced people. So administrative reporting is much more limited. Also, many of these countries that we're studying are in conflict, so it's really difficult and dangerous sometimes to collect good data. Also, they often don't have the capacity to do so. For example, some countries have not conducted a census in several decades, so it's really difficult to imagine that they will be able to track displacement where displacement occurs daily on people that are constantly on the move. So in Afghanistan, there are several existing data sources. There's survey data, where surveys are conducted approximately yearly. And then there's this limited administrative reporting that I just talked about. So against this backdrop of general data scarcity, there's a vast untapped resource in the form of mobile phone data that gives us very fine-grained insight into people's movements. So in this talk, I'll talk about how we're going to use this to study conflict-induced displacement. And of course, there are some very important limitations as well as privacy concerns that I'll get into at the later part of my talk. So for the rest of my talk, I'll just do a little bit more of a detailed introduction with specific goals and related work. And then I'll talk about the methodology, limitations, and then I'll conclude. So to be a little more specific about the goals of our project, so as I said, we're interested in studying the impact of violence on displacement. We make two contributions. The first is methodological. So we're interested in how we can use mobile phone data to estimate violence-induced displacement in a granular manner. And when I say granular, I mean daily on a fine geographic scale. So in Afghanistan, the finest administrative unit is the district, and we can think of it as like a county in the US. So this is the scale that we're trying to study. So the questions that we're interested in would be, for example, how do the odds of moving to a different district change some specific day after a violent day? And the substantive contributions that we make are looking at what the overall effect of violence on displacement is. Also, we're interested in specific factors that affect the relationship. For example, are there certain types of violence, for example, related to the Islamic State versus the Taliban, that would induce more displacement? And also, we're interested in studying the choices of people's destinations. So where do people tend to move? Does that change due to violence? And in this process, we confirm and test hypotheses from qualitative work. So I'll just mention several potential practical implications. So understanding the magnitudes, determinants, and choices of destinations of people displaced by conflict could help in targeting aid. For example, if we know that people tend to cluster in certain locations, or after certain types of events tend to go to certain types of locations, then it would make sense to target aid at these locations. Also, there's an argument to be made that areas that receive a lot of incoming displaced people could be locations of future instability. So it might make sense to allocate forces or target specific programs in these locations. And finally, if we know that, for example, certain types of events tend to impact displacement more, then that would help in the design of policies for prevention and mitigation. So just briefly on related work, there's two topics that are most closely related. The first is on conflict-induced displacement, and that's probably an area that this audience is very familiar with. Typically, there's the data sources include qualitative data, survey-based, as well as observational data. And the difference between this type of work and our work is we use this new source of data that allows us to do a much more granular and dynamic quantitative analysis. And then there is also a second body of work which uses non-traditional sources of digital data. For example, mobile phone data, data from Facebook, things like that, to study population flows. For example, there's some work that looks at changes in movement after natural disasters or the effect of airstrikes and drone strikes. And our work differs in the measurement aspect as well as the modeling, which enables us to estimate an average causal effect of multiple events on displacement. So I'll just get into the methodology. Right now, I'll start with the data sources. So we use two data sources, conflict data and then migration data. So for the conflict data, we use data recorded by the Uppsala Conflict Data Program. This is a publicly available resource. It's one of the leading sources on conflict data. So these data record single discrete violent events, and they are perpetrated by an organized actor and result in at least one death. And we have information about the location as well as the time from this data set. And we're interested in doing the analysis, as I mentioned, on a district level and for specific days. So we use events where we have that precision. And then for the mobile phone data, so these come in the form of call detail records. We have about 4 years worth of data from Afghanistan's largest mobile phone operator. So this is from 2013 to 2017. So just note the Taliban takeover is probably fresh on everyone's mind. So just note that this is several years prior. And so this data set has anonymized records for about 10 million subscribers or 20 billion transactions. A transaction occurs when a person makes an interaction with the mobile phone provider. So this could be a phone call or the transfer of a data packet. And when the person makes an interaction like that, they would connect to the closest cell tower to them. So in this way, when a person's making a transaction, we can approximately pinpoint their location. And when we have transactions over time, we can infer their trajectories over time. So the data come in the form, like in the table below, we have the hash, which is the anonymized identifier for an individual. We have the date time as well as the antenna ID, which tells us the closest cell tower at the time of the transaction. And so geographically, this is what the data look like. Afghanistan has about 400 districts. These are the locations of the violence, and these are the location of the cell towers. And we see that in general, there's a good overlap between the two. They're generally in the more populated areas in Afghanistan. So we're interested in using the phone data to measure migration. To do this, there's several steps that we need to take. First, from the transactions, the table that I showed earlier, for each user, we want to infer their most commonly visited district every day. And then from there, we want to infer a longer notion of residence. For example, we don't want to take into account if they go like on a day trip or like a weekend trip. So here we approximately consider week-long periods to be like a longer term residence for in the context of displacement. And then we aggregate this into a district day level, where for each district day, we want some measure of displacement, migration. So here we use the proportion of people who were observed to be in the district, what we say K days ago, and then we track if they're in a different district today. So we use K possible reference periods, where K goes from 1 to 120, and I'll explain in a second why we need all these possible outcome variables. So finally, we combine the district day level migration data that we infer using the mobile phone data with a similarly structured data set from the violent events data. So for the violent events data for each district day, we create indicator variables for whether or not violence occurred on that day, as well as for tau leads and lags. So we create these variables for violence occurring 30 days in the future up to 180 days in the past. So this is what the data looks like. So here on the vertical axis is the outcome variable for k equals to 30. So the proportion in a different district today compared to 30 days ago. And then on the horizontal axis is the each day for the 4-year period that we have. And then the vertical red lines are days in which the violence occurred. So we're basically interested in the relationship between this black line and the vertical red lines. So to model this, we use beta regression. So beta regression, you can just think of as an extension of logistic regression, where instead of a binary outcome, we have a continuous outcome from 0 to 1, which is suitable for the proportions that we have. And then this model is a panel fixed effects model. For people who are familiar with event study models, this is very closely related as well. So on the left-hand side, we have a transformation of the outcome variable. And then on the right-hand side, we have district and time fixed effects, as well as beta tau, t sub taus, where the t sub taus are the indicator variables that I just talked about. So the coefficient of interest here would be the beta taus. And these beta taus have the same interpretation of a logistic regression, where e to the beta tau is the multiplicative change in odds of being in a different district today for t sub tau equals to 1, meaning when violence occurred at lag tau versus if it did not occur, holding the other variables constant. And so we're interested in a causal interpretation, which involves several assumptions. So I won't go too much into the detail, but I'll just mention two key assumptions. The first is conditional exchangeability, which means that the precise day in which a district experiences violence is as if random, conditional on all these other things in the equation that I just showed you. So to say it more intuitively, it means that after accounting for district day and the surrounding violence, the occurrence of violence is unpredictable. So to be clear, I'm not saying that the violence itself is unpredictable. I'm saying that after accounting for all of these other factors, the exact date in which the violence occurs, so the residual violence that is unexplained is unpredictable. And this is consistent with how violence is meant to surprise. And the second key assumption is that the model is correctly specified. So I won't go into the details right now, but I'm happy to talk more later. So these are the coefficient estimates for the k equals to 30 outcome. So on the horizontal axis here, we have the days since violence, where so these are the taus, where tau goes from -30 to 180. And then on the vertical axis is the coefficient estimates for each of these taus. So it's e to the beta tau here. So the interpretation, for example, when tau equals to 0 is that if violence were to occur today, the odds of people, the odds of people being in a different district for those who were in the district 30 days ago increases by 2%. So here we can see that there is a clear effect of violence on the district's displacement. And there's an interesting result that displacement tends to anticipate violence. And we see this from the positive coefficients left of the vertical red line. So the vertical red lines at tau equals to 0, those on the left represent violence in the future, and on the right represent violence in the past. And this anticipatory effect was pretty surprising to us. But looking at qualitative evidence more closely, we found that NATO forces and the Taliban actually frequently warn civilians prior to major operations to limit civilian casualties. So this is a likely reason why we're seeing this type of anticipatory effect. And then, so now I'll move on to our analysis of the impact of a violent day. So previously we looked at the impact of surrounding violence on a district's migration. Now we're interested in tracking people who have experienced the violence over time. As I said, the Oh, 4 minutes. Okay. So first we define impacted people to be those in the district on the violent day. And so from the previous regression, for the k equals to 30 outcome, this means that this was people in the district 30 days ago. And the tau equals to 30 outcome meant that we were looking at violence occurring 30 days ago. So in other words, the interpretation is of that particular coefficient where tau equals to k is the effect of violence on migration tau days after the violence among impacted people. So if we were to repeat this for whenever tau is equal to k for all of the values of the outcome variables that we created, we can get the effect of violence on migration each day after the violence. So these are the results. We can see that displacement increases, spikes around 10 days after the violence. It's about 4%, and then it decreases to about 2%, but it stays positive even for months after. So the displacement is pretty persistent. So I have a few minutes left. I'll just talk about heterogeneous results for different types of violence. So as I mentioned, we're interested in how different types of violence differently impact displacement. And we can run the same type of regressions, but indicating out events for violence related to the Islamic State versus Taliban violence, for example. So we get two different sets of coefficients. In purple here, we see the effect for Islamic State related violence, and in red are Taliban related violence. And we see that for Islamic State related violence, there's a much larger impact, especially in the immediate aftermath of the event. And this is consistent with qualitative evidence that says that the Islamic State has been known to target civilians. They perform these vivid displays of violence, such as film executions, and that's a likely reason why we're seeing this immediate effect that's much larger. So we can do the same for other types of violence, and then we also do a much closer analysis of locations that people tend to go to. So I won't go into any of these details. I'll just share the main conclusions, which are that you can see that the 3 points here, we've already seen that Islamic State related violence has the largest impact, and provincial capitals, which are like the most economically developed and like most secure areas in a province, tend to have smaller effects. And then as a result of violence, people in non-capitals tend to seek safety in these provincial capitals close to home, as opposed to seeking economic opportunities, say, in a city like Kabul. So those are the things that we're able to infer using the fine-grained mobile phone data. And yeah, with that, I'll just conclude. There are some important limitations, and I'm happy to talk about them in the Q&A. But thanks for now.
Thank you very much, Kat. This was really excellent, and you're not over time yet. So if there were those last bullet points you wanted to stress, please.
Okay, well, okay, I'll just briefly talk about the limitations then.
Go ahead.
Yeah, so there are some very important limitations of the types of data that we use. So the mobile phone data has measurement error, where we're capturing, as I mentioned, these individual transactions, and people might share phones, so they might not be individuals that are using these phones. And then also people who use phones might not be the same as other people who don't use phones. So for example, most vulnerable people might not own phones, and they might be more likely to be displaced. So in that sense, we might be underestimating displacement. And then the types of movements that we capture are inter-district movements, but displacement might also occur within the district. And then obviously there are some very important privacy and data accessibility concerns with regards to the mobile phone data. And we only use for the analysis and anonymized data that are aggregated at a district day level. And then the violence data also has some limitations. For example, they're based on media reports, so there might be biases in the media reporting. For example, more populous areas and economic centers tend to have a larger media presence, so the events captured might be biased in a certain way. And then the last point is that there's some unique characteristics specific to Afghanistan, so we might be a little bit careful about how we generalize to other countries. So, for example, countries that have similar characteristics, like a long period of conflict or certain ethnic divisions, or like a patriarchal society, factors like that might affect the generalizability of the results. So I'll just stop there and take any questions.
Thank you. That's great. And actually, you're already answering some of the questions.
Okay,
so
perfect.
That's excellent. There was one question by Andres, I think, who was, yes, Andres, who was specifically pointing to the potential negative effects or risks of using this type of data. And you already mentioned it briefly here around the data protection and ethics. Is there anything else you'd like to mention on this point? Is there any risk that the wrong actors could get their hands on this data and use it to maybe track displaced people?
I mean, I don't think necessarily. I mean, it's pretty hard to get access to these data, so I would imagine, I don't think that is like the top concern, I guess. But I guess there are other sources of data that also capture aggregate mobility information. For example, Facebook has started releasing such aggregated mobility data. So there is some concern that other people could use these data, but they wouldn't be tracking individuals, since these data are released on a more aggregated level.
Yeah, I think that's clear. Thank you for your answer. There are actually quite a few questions, so I'm only going to have time to ask maybe one or two more. There is one I think you touched upon already, but if you want to add anything to this, what do you think could be the drivers of the difference in the effects between Islamic State and Taliban violence?
What the drivers might be?
Yes. Why is there a difference?
Right. So as I mentioned, the Taliban is known to specifically target civilians. So they do they do these like suicide attacks or events like that. Whereas the Taliban is more interested in like taking over territory. So they're interested in becoming like a governing force. So the types of events that are associated with such activities are different than the Islamic State. So, for example, they actually were known to warn people before an attack so that the civilians could get out of the way to limit casualties. So, in that sense, the nature of the events that are captured by the groups is pretty different. And
right, and
yeah, go ahead.
Sorry, that's also what you mentioned, right, when you were showing us this anticipation effect.
Yeah, exactly. Yeah.
Okay, excellent. There's another question. I'm sorry for the audience, I won't be able to ask them all, but maybe the last one could be around. Well, there is a comment by Laura saying that this methodology would be a great tool to show different vulnerabilities that IDPs and refugees face. Do you think that would be a way that you could use a similar approach to estimate cross-border movements too?
So cross-border movements are a little bit more tricky with this type of data because mobile phone operators typically operate within the country. But there could be other sources of data that might be more suitable for cross-border movements. For example, if like people have like Facebook data or Google has some aggregate. Yeah, exactly. So I'm imagining that those types of data might be more suitable.
Excellent.
Yeah.
All right. Well, thank you so much. I mean,
thank
as
you.
you can see, there's a lot of interest that
I'm happy to answer more questions offline or over email, so please feel free to.
Perfect.
Yeah.
And maybe do feel free, actually, all the speakers, do feel free to respond to the questions in the chat box as well.
Okay,
if you
I
get a
can do that.
chance. Maybe that's the way we can get more questions.
Okay, thank you
Thanks
so
a
much.
lot, and congratulations on this excellent work.
Thank you.
Right, so now we'll move on to our last presentation, certainly not least, of course, and a very promising topic around automated chat application surveys using WhatsApp. And I think for this presentation, we have on the line Jessica and Besa. Jessica, who is from the Immigration Policy Lab at Stanford University, and Besa from Mercy Corps. And I believe you will both be here presenting 2 case studies where you used automated surveys over WhatsApp to look at refugees and migrants in Colombia and in the US, if I'm correct. And please feel free to start whenever you're ready.
Thank you so much, Christelle. I hope everyone can hear me okay.
We can hear you. Presentation.
Great. It's such a privilege to be here, and especially to have had the opportunity to hear these 2 excellent presentations. I think our presentation nicely complements the last one. So we'll talk about our experiences using automated chat application surveys via WhatsApp. To do for our specific application, it was in the context of an impact evaluation. But this gets to the question of being able to survey or collect information from mobile populations, even across borders. So again, I think this is a nice complement to what we've already heard. So let me kick things off just by doing brief introductions. So I'm Besa Tesfaye. I'm Director for Research and Learning at Mercy Corps, with a focus on overseeing our research portfolio related to migration, displacement, and climate change. I work with a number of colleagues in different countries. So Mercy Corps is an international development and humanitarian organization working in over 40 countries. I work with those country offices to design and manage research, including evaluations of our programs. And I collaborate a lot with research institutes like the Immigration Policy Lab. So let me also introduce my colleague, Jessica, who is the Senior Program Manager at the Immigration Policy Lab, or IPL, which is a research lab at Stanford University. And Jessica and I, as well as other colleagues at Mercy Corps and Stanford and IPL, have been collaborating over the course of a number of years on research around migration and displacement. Next slide, please. So just to give you a sense of what we will touch on, I'll take about 10 minutes or so to talk a bit about the motivation for our research. We'll also go over sort of the methods that we used in our analysis, in our surveys, and share some preliminary results. And then hopefully, we're really hoping at the end we'll have some time to do an interactive demonstration of the WhatsApp survey. Next slide, please. So in terms of motivation, what really initiated this idea was Mercy Corps' ongoing humanitarian response to the Venezuelan refugee crisis. As many of you know, the situation in Venezuela has sparked one of the largest refugee crises in the world, compared in many aspects to the situation in Syria, with over 6 million Venezuelan refugees having left their country by the end of 2020. Roughly 1.8 million displaced Venezuelans are found in Colombia. And my organization, Mercy Corps, has been working in Colombia since 2006. One of the types of programs that we implement to support displaced populations is what we refer to as multi-purpose cash assistance programming. So this is essentially providing unconditional cash transfers to eligible households or individuals. And one of the programs that we were implementing in Colombia is known as Ven Esperanza. It is a project funded by the US government. And in its first phase, which began in August 2019, the program dispersed almost $30 million in the form of unconditional cash transfers to roughly 100,000 individuals in Colombia. This included both Venezuelan refugees, but also some vulnerable Colombian households across Colombia. So in terms of research, what we initially were very interested in was trying to use this program as an opportunity to test the effects of cash on migration decisions. We acknowledge that there's a large literature out there about the effects of cash on a number of different outcomes, including things like consumption, health, and other well-being outcomes. But what has been understudied in general has been the sort of the effects on mobility decisions, including return migration, which we were particularly interested in. Secondly, we were implementing this project in early 2020 when the COVID-19 situation emerged. So we also wanted to look at not only the effects of cash on mobility, but also a broader set of well-being outcomes during the pandemic, including things like income, employment, and housing, and so on. As well as looking at how those general conditions changed over time as we were collecting sort of a panel survey over the course of 9 months. Next slide, please. So for this purpose, we wanted to study the impact of this program. We had to survey a large number of people at multiple points in time. And we saw this as an opportunity to try to explore new surveying methods that would improve our ability to be able to keep in touch with this highly mobile population, which we knew was going to be a challenge. So there were several constraints and opportunities that we were considering when trying to decide how to conduct our surveys. First, of course, is cost. There are high costs associated with in-person surveys, and also in general with phone surveys, traditional IVR phone surveys. Oftentimes, this eats up a large percentage of our research budget. So we wanted to see how we could cut down on costs. There were also concerns around attrition, particularly, again, since we were doing these panel surveys and because we were surveying a displaced population, which we knew had a high likelihood of potentially migrating or moving again. We also saw the value of remote data collection as we began this project just months into a global pandemic, and the health and safety of data collectors and our teams, as well as the participants, was a really high priority. And finally, we wanted to be able to use commercially available technology, which we know institutions, particularly in the private sector, have relied on for a number of years for things like marketing or market research. And we wanted to leverage this technology in the work that we do as a nonprofit or as a research institute. Next slide. So all of these considerations led us to WhatsApp, which is an application that we've become very familiar with over the past couple of years, and I'm sure everyone here is also familiar with as well. The main thing to keep in mind with WhatsApp is that it's an application that allows users to be able to send text messages, voice messages, as well as make voice and video calls and share content, various types of content. It is hugely popular. It's estimated that there are about 2 billion users worldwide as of 2020. So there were some obvious advantages for using WhatsApp in serving households and individuals for the purpose of our study that we thought of immediately. One is users can access and use WhatsApp through either Wi-Fi or a mobile data connection, which means in almost all cases, it's a lot cheaper. In some cases, it's free to send messages or content, again, via WhatsApp rather than through SMS or a cellular network. And that's particularly the case when communicating internationally. Secondly, we saw that a huge advantage for us was that users can maintain the same WhatsApp profile and the same contact, the same contacts that they had before, as well as chat history, even when changing phone numbers or SIM cards. And this was really important, again, because we are working with a mobile displaced population, and it is common for them to change SIM cards or phone numbers in short periods of time. And then lastly, and Jessica will get into this more, but essentially through the business API that WhatsApp offers, we are able to automate sending and receiving data to and from a large number of respondents, making the time required to collect all of this information much shorter and also making it much cheaper for us. That being said, there were also some limitations, important limitations to consider that we considered and others might be considering. So in the case of text surveys, literacy requirements are still really important, and that can be a limitation in some populations. It is possible to do IVR surveys or voice surveys on WhatsApp, of course, but that limits in some ways the possibility of automation. Connectivity problems can also be a challenge in some geographic locations, so that's something to consider. And then lastly, there are privacy concerns, and by that specifically for us, what I meant is that this was due to the fact that phones, as was mentioned in the last presentation, phones are shared by multiple people in a household or sometimes even between households. So there is a need to verify the identity of the respondent, but there are still concerns about who can access the phone and potentially the survey information, the chat history. So just something to keep in mind, particularly for applications when there are sensitive questions being asked via WhatsApp surveys. Next slide, please. So I'm going to pass it over to Jessica, who's going to talk a bit more about the application and what this technology can actually do.
Excuse me. Thanks, Beza. So here's a screenshot of what a first message, an outbound message, might look like using this survey method. And we do hope to give everyone an opportunity to take a survey a little bit later on. One of the benefits of using an automated survey platform via WhatsApp is the ability to replicate and scale this approach quite quickly among program participants or research populations. You know, researchers make a number of decisions in designing surveys on any platform. If you've used Qualtrics or Survey CTO or any other comparable platform, a similar series of decisions are made when deploying surveys over WhatsApp. For example, you need to first identify your sample. Will it be a targeted outbound survey that you send to a specific number of participants? Will it be an open-ended survey that people can write into? Will you offer multiple choice or open-ended questions? As Beza said, will you present the questions as text messages over WhatsApp or as voice note recordings? How long will the survey be open and available? For example, we set our survey as a 2-day open period for this case. So just as you make a series of survey design considerations on other platforms, those are also necessary to make using WhatsApp. And then once you set this up, it's quite simple to expand the number of people that you make, as respondents or open the survey to. So that's a really exciting part of this method. Secondly, we did use various existing commercial technologies to supplement our ability to automate this platform. So as people are sending messages in and out of WhatsApp, there's not necessarily a person sending manually each message. We basically set up a logic series, just as you would on another survey platform, that can interpret questions and answers to a degree and automate the survey platform that way. So we use a platform called Twilio. We use a series of Google APIs to create a contact list to initiate the survey. We use the WhatsApp Business API to allow for this automated exchange. And finally, we use the Google Apps script to help facilitate some of this. We do have technical resources for this method available online. I'll share the link with that at the end. These are all publicly available APIs that we just nest together to help us set up this survey platform. And finally, as Beza was mentioning, sending surveys over WhatsApp, at least in our case, has proven to be more cost effective than in other situations. This is just an example that I put on this graph, but using the messaging fees for us as researchers to send these messages outbound to respondents, the estimated cost for a 10-question survey over WhatsApp was about 15 cents. And as Beza said, there may be little to no cost to the respondents, depending on their current cellular network plan or their Wi-Fi plan. This scales as you expand the size of your sample. And so for us, this has proven to be a highly cost-effective platform as compared to often very expensive phone or in-person surveys. I will note that there is a human investment and a human resources cost here. This is a new way of surveying, and there is an upfront investment required to learn how to link all of these various platforms and APIs together to set this up. We've estimated that it probably takes somewhere between 10 and 20 hours to learn this system to set up your first WhatsApp survey. And then once you're familiar with the technologies involved, it's quite easy to replicate and create a new survey, probably in the 4 to 5 hour range, depending on how long it is. So it is a new method, just like any new research tool that we all need to learn. There's an upfront human resource investment cost. But after that, and after the method is known, it's pretty easy to recreate and scale up to new applications. So I'm going to send it back to Beza to offer a little more context on the exact questions and approach that we took. We are going to talk primarily about the application in Colombia right now, but at the same time that we were testing this method in Colombia, another research group at IPL was doing the same with the Lutheran Immigration and Refugee Services in the US. So there's information available about both of these cases in the paper that's linked for this presentation.
Great, thank you, Jessica. So as mentioned earlier, the initial interest in doing this research was to understand mobility decisions of Venezuelan migrants and refugees in response to cash assistance through the program that we had in Colombia, and particularly return migration to Venezuela. We were also interested in learning about the economic and social well-being of our Venezuelan participants in Colombia during the COVID-19 pandemic. So our identification strategy for the first research question about impact was based on using the cash program's criteria for eligibility as a cutoff point for a regression discontinuity design. So essentially the program surveys individuals that are referred to Mercy Corps and then uses a vulnerability score to determine who is eligible to receive cash. Our plan was to measure outcomes of individuals that were just above and below the cutoff at 3, 6, and 9 months post-enrollment, while the program provided roughly $80 per month in cash transfers to eligible households over a 6-month period. So the baseline survey consisted of this in-person eligibility assessment, which was conducted in person by the program team, the Ven Esperanza program. And it collected general demographic and household information in addition to phone numbers of the respondents and, importantly, consent questions to consent individuals to participate in these follow-on WhatsApp surveys. Then at roughly 3, 6, and 9 months post-enrollment, we reached out via WhatsApp with shorter surveys that were focused on questions around mobility and a set of well-being outcomes, such as food security, healthcare access, schooling, etc. So when we started this project, again, around March 2020, the challenge that we ran into is, which essentially made it impossible for us to do the regression discontinuity design, was that we lost our ability to have a sizable control group because of the impacts of the pandemic. At a certain point, over 90% of the households that were being referred to Mercy Corps were deemed vulnerable and eligible for cash assistance. And we were lucky to have received additional funding to be able to support all of those additional households. So this was great for us. We're very happy about it, but it meant that our research study couldn't occur as a regression discontinuity design. However, we did continue to look at descriptive statistics, again, looking at the condition of our participants in the course of the pandemic, and that is going to be included in the working paper. But interestingly, we also shifted to focus more on the methods aspect of this, and we did a methods experiment which Jessica will touch on shortly. Next slide. So very quickly, I just wanted to share with you the descriptive statistics in terms of the response rates when we did the 3, 6, and 9-month follow-on surveys via WhatsApp. Among the approximately 2,600 people in our sample, around 20% didn't have a registered WhatsApp line. So we were only able to send out messages with roughly 80% of the sample. You don't see that on this table, but just keep that in mind. But of the total that were sampled, again, 2,600, roughly 50 to 60% actually started the survey. And importantly, of those who started the survey, over 96% completed the survey. So that is the last line, completed if started, that you see at the bottom. Then there's this line that says completed and matched. So that indicates if we were able to actually match the identity of the respondent during these follow-on surveys to the identity of the respondent who was surveyed at baseline. And we did this by asking for the individual's first name and year of birth. And we were able to match roughly 50 to 40% of those who completed the survey with the individual that did it at baseline. So overall, pretty high response rate and very high completion rates. Now I'll pass it over to Jessica, who can talk about how this kind of compared when we looked at WhatsApp versus other ways of surveying.
Thanks, Beza. So in the interest of time, I'm going to go a little quickly through this, but happy to answer any more questions, and there'll be additional details coming out in an updated paper released later next month. We had the opportunity to determine the feasibility and applicability of sending WhatsApp surveys compared to existing survey tools that are available not only to researchers, but also to program teams and service provision organizations like Mercy Corps. We used a separate group of individuals. These were individuals not a part of the panel study, but a second group who had been enrolled for the Venn Esperanza program, and randomized the survey delivery mode across 3 different platforms so we could assess how response rates and completion rates varied. We first used SMS, where we sent the survey questions over SMS messages using the cellular network. We sent another series of conversations and surveys over WhatsApp in the same method that was used in the panel survey. These could be received over cellular network or a Wi-Fi connection. Both of these surveys were set to be open for up to 48 hours for the respondents. And finally, a third group received the same series of questions over IVR, or interactive voice response, which was a phone call made over cellular data, and there were 3 attempts made for each individual in this group. I'm going to describe the results here in panel A. Here we're using the SMS survey as our baseline comparison. And so we're demonstrating the increased or relative rates of starting a survey or finishing a survey as related to the SMS response rates. And so here we can see that individuals who had a survey delivered over WhatsApp were 26 percentage points more likely to start the survey than those who'd received the survey over SMS. Likewise, they're 28 percentage points more likely to reach the 13th question and 46 percentage points more likely to finish the 25th question, which was the end of our survey. They're also 10 percentage points more likely to complete the survey if started, again, as compared to those who received it over SMS. Likewise, for IVR, there was a 20 percentage point increase in those who started the survey, who received it as a phone call, compared to an SMS. In the second panel, we delimit our sample just to those respondents who have an active WhatsApp profile. So again, there's about 20% of our WhatsApp group that does not have an active WhatsApp profile, and so they actually never received the first message. And so when we delimit just to those who have a WhatsApp profile, there's a 43 percentage point more likely to start the survey compared to those who receive it over SMS. These results will be available in the future, so you can take a look. I know we need to move into the question section, so I'll just open up this page here. If anyone is interested in testing a WhatsApp survey themselves, you can scan the QR code with your phone. You can open the WhatsApp platform and send us a message at this phone number. Or you can use the following link in your WhatsApp web account. I will leave this up for the time being, and thank you all for learning about this. We do have technical resources online. I'll switch to that slide in a minute after you have the opportunity to use this information to test the survey. I think we've really benefited from the opportunity of testing and learning using these commercially available platforms to apply these technologies to service provision organizations and research opportunities. It's provided timely, cost-effective data with a mobile population over time. And so we'll be really excited to hear any questions and share a little bit more about this method. Thank you.
Thank you, Jessica and Beza. This was really, really interesting. I, for one, as research manager at the Internal Displacement Monitoring Center, I think I'd love to use this approach in our research. We are also obviously facing resource limitations, and this would be a great way to try to bridge some of those issues. I just want to remind everyone who's on the call today that the papers of all of our presenters are already online on the conference's website. So please download them, read them. There is more information there. And I believe you all have your contact information on those papers. So you can also be reached this way. But if there are any questions to ask immediately, we can probably take one or maybe two. If not, I have one immediate question to both of you, just wondering if you are already foreseeing other case studies where you will be you'll be using this. And I don't think we should even say case studies, because it's not just for research, right? It really does have a concrete operational impact, or potentially so anyway.
I'll just jump in really quickly and then turn it back to Beza. I do want to acknowledge that while we were using this application with Mercy Corps in Colombia, there was another team at IPL using the same method with Lutheran Immigration and Refugee Services in the US with resettled refugees, and found success and opportunities in applying it in that context as well. I can already tell you that we're working with other partner organizations to embed this engagement method domestically and in other international contexts. Certainly one limitation of using WhatsApp is that it does need to, the group that you're engaging with needs to either already have it or be willing to learn how to use this platform. So that is one limitation to consider. I think we've been really excited about the potential additional applications that are available. And something that is really important for us is to make these resources publicly available. So that website that I just linked up, and there's a link in our paper, there's an online public technical manual so that anyone can adapt what we've done. And in fact, since releasing that about a year ago, we've had crowdsourced suggestions on ways to update the methodology. Yeah. So it's really exciting to hear about other groups that are applying this as well.
That's excellent. You are raising the limitations of the methodology, and there is one question that we've been hearing also for mobile phone data, right? But I think we also need to touch upon the privacy concerns here, because it's more than mobile phone data. In this case, you actually know the people you're engaging with, and you're holding this information. So is there any particular concern you have or you've had, and how you've tried to respond to these risks?
Mm-hmm. It's a great question and really important. I think I would first encourage anyone who's considering this to really read in depth the privacy standards of the various APIs and businesses that are involved. These conversations on WhatsApp do remain end-to-end encrypted, which is a kind of core facet of the WhatsApp platform. There are additional ways that you can encrypt and de-identify the exchanges when collecting the data and using these APIs together. It's really important to be upfront about the usage of this platform, just as we do in any survey platform. It's critical to be clear about that at the outset in the consent experience with participants and respondents, so that they understand the usage of WhatsApp. I will say that using WhatsApp, at least in this context, is pretty common in a personal sense, and so participants are at least familiar with the platform and the commitments that they make in that regard. I don't want to go into all of the details right now, but there are a number of additional privacy safeguards that are embedded within the WhatsApp Business API in regards to, no content of any of these conversations is ever made available to anyone besides the respondent and the business use that the researcher or program team may be using And so there is not a concern of specific responses or answers getting out. I will encourage everyone to take a look at this, and it's definitely a consideration that needs to be brought in.
Absolutely, a very, very important consideration in the context of forcibly displaced people. So unfortunately, we are now out of time. There are some more questions in the chat box, so please do reach out to our speakers today via the platform, the website of the conference, the papers. You have their names now and their affiliations, so hopefully you can find each other on the World Wide Web. And in the meantime, we're going to have to take a little break before our next session. So I just want to thank all of our speakers today again for their wonderful presentations, our audience for their amazing questions, and of course the organizers of this great conference that is not over. We'll just take a 15-minute break and the next session will start on returnees this time. So thank you all again and have a wonderful rest of the day and rest of the conference.